Hello, everybody. Welcome back to another session of Pre-Calculus with me. Today, we're going to be talking about the second part of the polar graphing. And to be a little bit more specific, we're looking at the general equation R is equal to A plus B cosine theta, where A and B are supposed to be real numbers. Now, there is a specific name for all these types of graphs that we're going to be drawing out. The name for it is called Limacon, or in English, it's going to be called cardioid. So either one of those will be the appropriate name for it. So let me just kind of write it down. So Limacon, okay, so that's French, or cardioid. So cardioid. Okay, so let's go ahead and get into it to see what these graphs would actually look like then. The first one is R is equal to 4 plus 4 cosine theta. So what I'm doing is I'm looking at specifically what happens if A is equal to B when it comes to the absolute value or something like this. Actually, I think it's probably best if I just write, so A is equal to B. So let's go ahead and create a chart so you can see what exactly is happening. Now I'm going to go ahead and choose values of theta so I can solve what R is equal to. And according to what we've been doing so far, I don't want to use like every single value of theta, but instead I want to use maybe like say just the ones that are multiples of 90s just to make it a little bit easier and kind of like just interpret what happens in between to minimize the amount of work. So let's go ahead and write that 90, 0, 180, 270, and then 360. Okay. So for each one of these, if I solve for R, we are going to have the following then. The first case, it's going to be 4 plus 4, which is equal to 8. The second one will be 4 plus 4 cosine of 90, which is 0. So that's going to be equal to 4. The next one is going to be 4 minus 4 is equal to 0. After that is 4 plus 0, which is equal to 4. And finally, for 360 degrees, that's 4 plus 4, which is equal to 8 then. So you can see the nice part is that your radii are going to be non-negative. So that means that we don't have to worry about going in the opposite direction. Now, for the graph itself, let's see. So at 0 degrees, we are a radius of 8. So that means it's going to be somewhere out here. At 90 degrees, we are going to go out in the radius of 4. So 1, 2, 3, 4. So something like this then. At 180, we're going to go to 0. So that's a pole. At 270, we're going to go to 4. So 1, 2, 3, 4. And we're going to go down in 4 in that direction. And then finally, the last one's 360, which is going to be 8. And that goes back to the original point. So let's go ahead and kind of identify what's happening from each quadrant. For the first part, from 0 to 90, that is going to be quadrant 1. And you'll notice the value is you're going to go from a radius of 8 going to a radius of 4. So that means as 0 rotates towards 90 degrees, your radius is going to decrease from 8 to 4. Now, in terms of how that actually looks out, it's probably going to do something like the following then. Okay, so it's going to curve inward like this. So you can see that it's going to go and decrease and decrease and decrease. Okay. Then after that, from 90 to 180 degrees, your radius is going to go from 4 to 0. So what that means is, so from here, 90 degrees going down to 180 degrees, your radius is going to get smaller and smaller such that eventually you're going to get to the pole. So graphically, you can see that it's going to go inward like the following then. Then after that, from 180 to 270 degrees, your radius is going to be for quadrant 3, and it's going to increase from 0 degree back to the radius of 4. So that means it's going to be symmetric to what we just drew. And finally, from 270 to 360, that is going to be in quadrant 4. And for that part, you're going to go out from radius of 4 to a radius of 8. So that means that it's going to look something like this then. So let me just kind of erase the top part so it looks a little bit prettier. But there you go. That's going to be the shape of our first limacon or cardioid. Okay. So, and for me, I usually like to draw the path so you can see the direction that it's going towards. Now, one way to kind of recognize it is that it looks kind of like a heart. So that's what you're expecting as a graph, so long as your absolute value of b is equal to absolute value of a, because you go through that origin right there. So it's kind of like a heart shape, and that's why it's called cardioid. But for me, I say that it looks more like a butt, but that's just me anyways. To also show you this on Desmos, just so that you can, verify my answer, we're going to go ahead and go over here. Okay, so let's go ahead and take a look. And we'll go ahead and punch in the equations. Let's see what happens then. Okay, so we have 4, and then we say plus 4, and we are going to put in cosine of theta. And so as you can see, that's going to be our cardioid shape. The shape of it is not exactly a circle, as you can kind of point out. In fact, it looks kind of like a circle. It has a curvature of a circle, but not quite. But yeah, that's the idea behind that one, okay? So now let's go ahead and move on to the next piece then. What happens if the value of b is a little bit smaller, okay, than a? So that is to say the absolute value of a is going to be greater than the absolute value of b. Well, for this graph, let's do the same thing. We'll go ahead and create a chart. So here's theta, here's r. So 0, 90, 180, 270, and then 360. Okay. Let's see. So when theta is equal to 0, we get 4 minus, looks like it's 0, so the answer is equal to 4. At 90 degrees, we get 4 minus 2, so that's equal to 2. Then we have also, let's see, how about 180 plugged in? We get 4 minus 0, which is equal to 4. And then 270, we have 4, and then looks like plus 2 this time, so we get 6. And the last case, we get 4 minus 0, which is equal to 4. So unlike the first problem, you'll notice that your radii are never equal to 0 or anything that's negative. So that tells me that it will never touch the pole, the origin, basically. So now let's go ahead and sketch out the graph. 0, 4, that is going to be over here. 90, 2, that is going to be over here. 180, 4, that is approximately over here. And then 270, 6, so 1, 2, 3, 4, 5, 6, so that's down here. And then finally 364, which is going to be at the same origin. If you look at the curvature of it, and remember how we're rotating counterclockwise starting from the 3 o'clock position, your curve is going to come out approximately like the following. Remember, this is a circular motion still. You're going counterclockwise just like you are on the unit circle. But the path, right, the circumference is not exactly well, it's not really a circumference, but it's but the surface area, the outer rim, is basically not going to be the shape of a circle. Okay, so here is going to curve outward to this point, and then now it's going to go back this way like this then. So if you follow the arrows, you can see what the curve looked like. And this shape of it is still in the same category as a Limacon, but the shape is more like a guitar pick then, as you can see. So once again, I'll go ahead and show you this on Desmo just to kind of verify our answer. So let's see here. We're going to go ahead and change our equation. So it's going to be 4. And I do believe it's minus 2, and it's also cos, and it's also sine. And there it is. See, so it's just as we said, it's almost like a circle, but not quite. It's almost as if, like, if somebody is pushing down on that circle on the top, and as a result, it's like kind of like a little bit flatter. Okay. So that is kind of like the second case, right? So we looked at what happens when A is less than B. We also looked at what happens if A is equal to B, the absolute value of each one. And so the last case is what happens if A is going to be less than B. So that is going to be this last one over here. Okay, so the absolute value of A is less than B. Now, what that tells me, just looking ahead of time, is that we're going to expect your radii somewhere to be negative. So we have to be very careful about this one. All right, so here we go. Theta and then r. Now, let's see. If I am going to solve for this, we're going to have 0. We're going to have 90. We have 180. 270, 360, so the usual suspects. So plugging into each one, the first piece we'll get 4 plus 6, which is equal to 10. Second piece, we get 4 plus 0, which is equal to 4. And at 180, we get 4 minus 6, which is equal to -2. Now that is where it's going to be a little strange then, you'll see in a little bit. Let's see, 270, you get 4 plus 0, which is equal to 4. And then finally, 360, we get 4 plus 6, which is going to give us 10. So first, we're going to go ahead and isolate now those points. The first one is going to be at 0 degree, comma 10. So that's all the way out there. 90 degrees, you have 4. So 1, 2, 3, 4. So that's going to be somewhere over here. 180, that's -2. That's going to be in here. And then 270, comma 360, 270, comma 4, that is going to be down here. And then finally 360, comma 10, that goes back to the original spot. Okay, so same as before. Looking at quadrant 1, okay, so from 0 to 90 degrees, we have a radius of 10 going to a radius of 4. So you're going to spiral inward, just like what we've been having so far. So you can see that as theta increases, or theta is rotating counterclockwise this way, the value of r is getting smaller and smaller. Now, for 90 to 180, now this is where it's a little unique because what you're getting is that 180 is going to be -2, which is back here. Now, thinking about how trig function actually works out, in order for you to go from 4 to -2, I claim that somewhere between 90 to 180 degrees, you're going to have a value of theta that goes through 0. Okay, repeating it one more time. In order to go from a radius of 4 to a radius of -2, I claim that somewhere in quadrant 2, somewhere between 90 to 180 degree, there will be a value of theta where the radius, when you plug it in, is going to equal to 0. So what that tells me is you still actually go through the origin somewhere. Okay. Now, at first, those values of r are going to be positive because you're going to go from 4 to 0. And then afterwards, that's where your radii are going to be negative because you're going to go from 0 to -2. And once that happens, you're not graphing within the, sorry, let me just go ahead and go back here. You're not going to be graphing in that same region, right, of quadrant 2, but instead you're going to be graphing in the vertical angle portion of it down there. So what that tells you is that your curve is going to go from 0, and then afterwards, you're going to curl inward into that -2 into the vertical angle part. So instead of over here, you're going to be graphing somewhere over here. So the curl, let me just kind of draw it on the side. It looks kind of like this. Okay, a little freaky, isn't it? Let's see. To continue on, you're going to go from -2 to 4. So that means that in quadrant 3, right, you're going to first start off with the negative portion, right, of this part somewhere over here. Your radii are negative, so that means you're graphing in the vertical angle, which is in quadrant 1. So that means it's somewhere over here. And just like in quadrant 2, you're going to go through 0 for some value of theta in quadrant 3. So that means you must go back into or spiral back into the pole. And then from there, you're going to then go to 0. You're going to go from 0 to 4. So then that is how you're going to go back out into this part over here, which is going to be 273, 4 then. So now, finally for the last part, from 4 to 10, that is going to look just like what's above it. And in fact, I can pretty much say that the quadrant 3 and quadrant 4 is really just a reflection of what happened in quadrant 1 and quadrant 2. But yeah, about the x-axis then. So the curve is going to go out this way then. Okay. So in your final graph, your curve is going to be something like this then. So it basically curls inward into through the pole right here. That is going to be our pole. And then it's going to go to the point where you have the radius is negative on the x-axis, spiral back out, and then spiral back in. Okay. So once again, just to verify, so we're going to go ahead and go to Desmo to show you this. Let's see, our equation, I do believe, let's see, is supposed to be plus and then it's going to be 6. And did we use sine or cosine? I think it was cosine. So let me go ahead and change that. So delete, delete, delete. Let's see. So cosine of theta. Okay, so there it is. Okay, so yeah, you can see that you have that small little loop inside because of the radius that's -2, and then you have the rest of the curve then just as before. Okay, so that is so those are the 3 types of curve that you're going to get for the general shape of r is equal to a plus b cosine of theta. Okay, or r is equal to a plus or b plus or minus b cosine of theta, or a plus or minus b sine of theta. Okay. The cosine or the sine, it basically tells you the orientation of the graph. Is this going to be opening upward or downward? But more importantly, just think about what happens with the values of a and b. If you have absolute value of a is equal to absolute value of b, you have a shape that looks kind of like a heart, okay, or like a butt, depending on how you look at it. If you have the scenario where absolute value of a is going to be greater than the absolute value of b, then your limacon is going to look kind of like a guitar pick. So that's going to be our shape of it. And finally, for the last part, if you have the absolute value of a is going to be less than the absolute value of b, then your limacon is going to curl inward like this, and that is going to be the shape then. It's kind of like having a hemorrhoid inside.